So this is a pendulum. Okay, we've all seen this before. We have a rock or something that's tied to the ceiling, and we're going to pull it up here, and we're going to let it go. And it's going to swing like this. Okay? Now, we know that it's going in a circle. Okay? Because it's a circle. Even though we're not specifically going in a full circle, we're using a portion of a circle. So that's going to help us in that sense. Okay. So our first thing now is to make a free body diagram. All right? And we've practiced. Oh, well, first let's do our questions. Is there gravity involved? Well, yes, there is. The rock is being pulled down. Okay? Is it on a surface? Well, no, it's hanging in the air, so it's not on a surface. Is there friction? There's some minimal air friction, but not enough to say that we're going to calculate it. Is it being pushed or pulled? Well, it is tied to this particular part, so this here is doing that, so we've got a push or a pull. Is it going in a circle? We already determined that yes, it was. And we know that the circle is going toward the center, acceleration is going toward the center, so acceleration is going in this direction, positive. Okay, so that becomes an important part. Acceleration is going this way. Okay, so now let's do our free body diagram. All right, so here's our spot. Do we have gravity? Yes, we do. So we have the force of gravity going in this direction. We're not on a surface, so therefore we have no movement this way. We don't have any friction. Do we have a push and a pull? Yes, we do. So we have a push and a pull, and that's going in this direction. So that's going to be our force T, not F, T, which is going to be tension. Okay, we've talked about tension. All right, so there's our free body diagram. We don't have anything going this way. We only have these two things here. Those two things cannot be the same. Okay, they can't be equal because otherwise the rock wouldn't hang down. All right, so now we're going to see what we've got here. So we've got force net equals MA, Newton's second law. Well, this is centripetal, so it's going to be AC. So now, what's our force net? Well, our force net is going to be the force of gravity minus the force of the tension is going to equal MAC. So for this particular problem with a pendulum, this here is the equation that you would use. Later on, we're going to do some problems where you'll have a pendulum, and you're going to start with this one here. This here, this AC, we would change to V squared over R. Oh, so we could then solve for all of the parts. We could figure in what gravity was. We could figure out what the tension was. We could know what the mass of the rock was. We could know what the radius of it was. We could do all of those things and figure out whatever part we wanted to. In this one, there's 1, 2, 3, 4, 5 different variables. We have 4 out of the 5. We can solve for the 5th. All right, a tetherball game. We've all seen that. That's when you have a ball, there's a post, and there's a chain with a ball that comes off of it, and you spin the ball around the post. Okay, so it's fixed to the post, and the ball is there. Okay, so a couple of things. Let's go through our questions first. Number 1, is there gravity involved? Well, there has to be. The ball's going around, so there has to be something, so there is gravity. Okay? Is it on a surface? No, it's in the air. It spins around, so not on a surface. Is there friction? There is some friction, but friction in this case is going to be coming either out at us. If it's coming out at us, it's going back into the board, and therefore we don't have to worry about friction. Is there a push or a pull? Well, yeah, it's attached to a rope. So there is a push and a pull. Is it going in a circle? Yes, it is. It's going around the post this way. So yes, it's going in a circle. So yes. And which way is the circle? Well, the circle is in this way here. So our acceleration's going that way. So Direction is going to be acceleration in this direction is going to be positive. All right, so now let's go to our free body diagram. And now this is going to be a little bit weird. We're going to have to do some things here. All right, so here's our point. We said we had gravity. So F of G is going here. We had this going off at an angle here. So this is going to be F, what do we want to call that? We want to call that, oh, Ft, right? Because it's tension of it pulling it that way. All right. It's not on a surface, so we don't have anything that way. And friction we don't have. So there's our part. So let's really, oh, wait a minute. We have a problem. Because this is X and this is Y. So we have a problem because if we go to our formulas, we're in trouble. Because the only thing that really matters here is going to be this section here. So, Pythagoras, your friend and my friend, has come back to help us again. There he is. Pythagoras comes down. This here is going to now be F of X in the Y direction. Well, it's going to be F of C or F of A in the Y direction. And this is going to be F of A in the X direction. Whew. Well, now, wait a minute. We do know that the object's tied there, so this one here and this one here are going to be the same. Okay, so those two are going to cancel out. So, all right, so let's take a look here. So we're going to have F net equals MA, and we're going in a circle, so it's centripetal. So now let's figure out what F of net is, and that's going to be F of AX equals MA centripetal. And there is our equation. Because our other ones are all going to be taken care of and are all accounted for. So that's going to be the one that matters, and that's going to give us that part there.